Imagine an electric vehicle that could travel thousands of kilometers, a smartphone that could operate for days, and devices capable of storing more energy without requiring a larger battery. For many years, engineers have been trying to achieve this goal, but they have continuously faced one major barrier: not the motor, not the software, but a reaction happening at a scale smaller than the human eye can see, deep inside every layer of the battery. A place where billions of lithium atoms are constantly moving. To understand why solid-state batteries could change everything, first, we have to open a modern lithium-ion battery. Inside the metal casing, it is not simply a block that stores electricity. It is an extremely precisely engineered chemical system. A cathode layer containing lithium atoms, an anode layer usually made from graphite, and between them is a liquid electrolyte. When you charge the battery, a process at the atomic level begins. Lithium atoms inside the cathode lose electrons. They become positively charged lithium ions. These tiny ions start their journey through the electrolyte. They travel through microscopic pathways and enter the layered structure of graphite. Meanwhile, electrons cannot pass through the inside of the battery. They have to move through the external electrical circuit. This flow of electrons is what provides power to the device. This process happens thousands of times. But this system has a major limitation. Graphite works like an atomic parking structure. Each lithium atom needs a place to stay, and the structure of graphite can only store a limited amount of lithium. If you want to store more energy, you need to increase the size of the battery. This is one of the reasons why electric vehicles require massive battery packs. Scientists have known about a better solution for a long time. Remove graphite and replace it with pure lithium metal. In theory, this is almost the perfect anode. It is lighter, it can store more energy, and it does not require a carbon structure taking up valuable space. But there is a dangerous problem. When lithium metal is charged repeatedly, it does not always return to its original position perfectly. Tiny lithium crystals begin to grow. They are called dendrites, like microscopic needles growing inside the battery. Over time, they can penetrate through the separator layer, creating an unwanted connection between the two electrodes and causing the battery to fail. This is where solid-state batteries appear. The idea is not simply to create a new type of battery. It is to completely change the environment where lithium ions move. Instead of swimming through a liquid electrolyte, lithium ions must travel through a solid material, a crystal network engineered at the atomic level. From the outside, this material may appear completely solid, but at the atomic scale, it contains tiny pathways that allow lithium ions to move. The ions jump from one position to another, moving through ceramic structures, sulfide materials, or special polymers, like an invisible highway system built for atoms. But this is also the greatest challenge. In liquid batteries, the electrolyte can flow into every tiny space. It can easily contact the electrodes. But solids behave differently. When two solid surfaces are placed against each other, they actually only touch at extremely small points. Nanoscale gaps between them can block the pathway of lithium ions. This is why manufacturing solid-state batteries requires extreme precision. Each material layer must be compressed with the correct pressure. The surfaces must be almost perfect. The chemical composition must be controlled in every detail. A tiny defect at the microscopic level can affect the entire battery. This is why, even though the idea has existed for many years, solid-state batteries remain extremely difficult to mass produce. The problem is not creating a battery that works inside a laboratory. The real challenge is creating millions of identical batteries, stable, durable, and affordable enough for the real world. If this barrier can be overcome, solid-state batteries could unlock a completely new generation of energy storage. Not because they are a magical invention, but because they solve the problem at the smallest scale. The place where lithium atoms meet. A place where a layer of material thinner than a human hair could decide the future of electric vehicles, robots, and the entire world of technology.